Supercomputing. Rick's based at the University of Bristol, and today we're going to be doing a quite sort of broad talk, a little bit different from what we normally do, talking more about careers at Bricks, about our team structure and our work stream structure, and we're going to talk a bit as well about our approach to software on sort of self-service and users bringing their own software stack. So to start off, as we're talking about careers, Tom and I are just going to give a little bit of background on ourselves and how we ended up at Bricks. So for myself, my education is in physics, and previously to joining Bricks, I was a RSE at Cardiff University for just under 7 years, where I sort of was embedded in the School of Biosciences and primarily working in pathogen genomics. And a lot of my work was in public health, working closely with Public Health Wales, and joined Bricks back in June 2024, where I spent time on a few different work streams. Currently, I'm sat within the user services work stream, where I lead on training, and also the allocation and billing work stream, which consists of work on Wardle, our portal, onboarding projects, and ensuring compliance. Tom, I'll just let you talk about yourself.
Hi there. So I'm Tom. So I was a chemical engineer in training at the University of Manchester, or should I say UMIST? Come on, stick with UMIST if you know the history of that organisation. So I then joined Sister Dano's Met Office. So I've been trying to recognise if I recognise the names from the Met Office here, but I think my time there was a long time ago. So I supported the unified model, a lot of Fortran code, and Subversion was the repository, code repository software of choice when I was there. And it was part of the sort of operational support and engaging with ECMWF. So it gave me an opportunity to see many different communities, be part of many different software projects across Europe, which was a great time as an engineer to see that. I then moved to Cardiff University, so we did overlap. I was labelled a parallel programmer, which sounds quite grand and quite sort of be there busy in getting software working on supercomputer, but it was a broad range of support. So I supported general HPC, so there's a number of projects. We had our local, with Supercomputing Wales, which Anna's already mentioned. Also had HPC Wales, if people know the history of that project as well. And we provided training resources for a lot of the users, so a lot of our documentation and training videos. I was there during COVID, having to generate recordings and be on Teams calls for a lot of that. And also part of that was the support for GW4 Isambard. So GW4 is the collaboration, being in Exeter, hopefully you're probably mostly aware of that. So Exeter, Cardiff, Bath and Bristol. And the Isambard system was there to be used by researchers of those institutions, as well as from what was, or tend to be only EPSRC, but now would be UKRI. I then joined Bricks at the same time, I think, wasn't it, June?
Yeah,
we were within a week of each other. So I'm now leading on the cybersecurity side, so I'm quickly being brushed up on cybersecurity skills, and then also on the infrastructure. So I'm the person behind the curtain, like the Wizard of Oz, getting things done, but no one really should see me. I've been leading the sub-team of infrastructure in Isambard 3, so a lot of people that may notice my name is from my Isambard 3 technical work, and also on Isambard 2. If you use Isambard 2, I may have been a responder on one of your support tickets over the years. But I also provide advice because I'm sort of a specialist within the team. I sort of have a general overview of all the work streams, which you'll find out more in a bit, and sort of get involved and get my hands dirty in a lot of different projects and skills. So that's me, and I'll hand back over to Anna to do the first half.
Thanks, Tom. So just briefly, I'm sure a lot of you are already familiar with us, but we're Bricks, we're the Bristol Centre for Supercomputing, and we host Isambard AI, a dedicated AI research computer, which is part of the UK's AI research resource, AIR, along with Dawn at the University of Cambridge. And we also host Isambard 3, a tier 2 machine for more traditional sort of HPC. And also as well, in addition to those two, we host Blue Crystal 5, which is the University of Bristol's local supercomputer. So talking a little bit about our users, so a very high number of users, over 2,000 users across 600 projects, across our free supercomputers. We have both academic and industrial users, and allocations are made through UKRI and also University of Bristol for their allocation, and for Blue Crystal 5, and also through the GW4 Alliance, who run Isambard Free. So for anyone who's not familiar, GW4 is Bristol, Bath, Cardiff and Exeter, who run Isambard Free. So for Isambard AI in particular, the awards can range massively in size in terms of the number of GPU hours allocated, sort of dependent on the access route, and usage cases can sort of be very small. Sometimes people running sort of 1 GPU jobs to people running jobs requiring sort of hundreds or thousands of sort of GPUs. And projects tend to be short-lived. So most projects run for sort of 3 to sort of 6 months. And we see like a very wide range of domains across sort of science and AI. So we have a very sort of large user base and very sort of broad use cases. So talking about our sort of work stream structure within Bricks. So it's sort of segmented into these sort of different work streams, where each work stream has a lead, and each work stream has a sort of set of responsibilities to deliver. So our CTO Sadaf has sort of encouraged us to sort of think of it as a sort of ship. So these sort of functional elements and decks of a ship. It's a sort of model we're thinking about. And so some of the sort of processes that we have may be like overseen by a work stream, but sort of there can be sort of cross work stream responsibilities. So some examples of that would be CAF, the Cyber Assessment Framework, is owned by the cybersecurity work stream, but there may be responsibilities for sort of CAF that have to be implemented, say by the infrastructure work stream. And particularly a lot of the processes that sit within user services, such as documentation, training and service desk. There are some sort of team-wide responsibilities within that, but sort of user services are sort of in charge of those processes. So talking a little bit about the roles and structure of the technical team itself. So at the top, we sort of have leadership with our CTO Sadaf and the AI supercomputing infrastructure lead sit within leadership. We have workstream owners such as Tom, infrastructure specialists are in charge of sort of workstream. And then we have these varying roles, engineers, associate engineers and support engineers, who have sort of different levels of sort of responsibility, sort of dependent on their position. So engineers can be responsible for sub-work streams, such as myself. I'm an infrastructure engineer and I head up the training sub-work stream. And we also have some specialized roles as well for cybersecurity and networking. So our sort of roles and sort of workstream structure sort of fits into our sort of cybersecurity sort of zero trust design, influenced by this NIST paper. So we have these sort of this segmentation into these 4 sort of distinct zones, and role-based access control means that sort of no one in the team has admin access to everything. We have access to the sort of the zones and the, that we need to be able to do our job. So this sort of high segmentation happening. So all of us essentially are infrastructure engineers. We're sort of not officially sort of segmented into the sort of sysadmins and sort of RSEs. So there's this sort of shared ownership and culture, and there's a lot of sort of encouragement around sort of sharing knowledge at our sort of weekly technical meetings, and we sort of keep our work stream meetings open as well, So there's a sort of opportunity to sort of people to learn a sort of broad range of skills, and it's encouraged as well that sort of we move around sort of work streams and sort of build this sort of strong base of knowledge. So moving on to sort of our kind of second part, that we're going to talk about our approach to delivering software. So we call this sort of bring your own software stack. As you saw in the sort of previous slide, we're supporting a very high number of users across a broad range of domains. And these users will have sort of established applications and stacks and workflows that they want to bring with them. And our sort of approach is sort of very documentation led, sort of empowering sort of people to install sort of software themselves through having very high quality documentation. That sort of covers how people can sort of use sort of Conda and SPAC and containers to install their software. And we sort of do a little bit of work as well on sort of some sort of more common sort of applications, like making sure people are sort of easily able to install common like ML frameworks on Isambard AI, for example. So we sort of use this approach as well because it sort of promotes reproducibility of research. Like certainly you shouldn't say, you know, sort of if you got your sort of publish your paper, you shouldn't say, oh, I ran this on Isambard AI or Isambard 3. You should have a reproducible sort of software stack that you can sort of move with you. And we encourage the autonomy for sort of researchers and our users. And I think as well as sort of this kind of really highlights the sort of valuable role of RSEs as well in being able to sort of implement this. So I'm just going to pass over to Tom to talk about SPAC and containers a bit more.
How long have I got? 5 minutes. Okay, good. I saw the 1 minute and I was panicking 1 minute there. Right. Okay. So quick show of hands to see whether so who's used Isambard AI or Isambard 3 in the room right now? About a third-ish. Yeah. And who's used SPAC in the room? Yeah. I'm just trying to gauge the kind of thing. So as you may or may not know, then the Isambard 3 and Isambard AI is based on an ARM architecture. So it's not x86, it's not the usual stuff that you usually see in clusters that you may have at your universities. So the first challenge when we were trying to design, well, how are users going to install their software? Because it's going to be a different platform, they're going to have to probably recompile, probably have to build their software from scratch. So we wanted a solution, and SPAC, if you don't know what SPAC is, you can probably go, I should have probably put a website link or something on here, so spac.readthedocs.io or something like that will take you to there is a way, it's developed by some, I think originally NERSC in US labs in America, as a way of trying to build that dependency chain. So if you ever looked at some of these dependency chains for software, you'll see this big mess of spaghetti where software can have a very complex dependency chain. And they want to make sure in the US labs really is that kind of what is actually being built, what's the provenance of all the software that you're using, because they don't want us to run any old software on their system. So SPAC was designed on that sort of ground up of sorting out your dependencies. So what comes along with that benefit? Reproducible build. So if you choose SPAC to do stuff, you should be able to reproduce what you're running on a different system. If it's a different architecture, you've got problems about architecture differences, but we won't go there yet. You've got the dependency management. So if you try and build some of these Python tools, now Python, my head actually explodes when I see some of these Python projects, especially in the AI world, where you're pulling in things from different GitHub repositories and dependency chains to build in all this stuff and SPAC tries to resolve that, although it has its own issues with Python. But mainly, if you're trying to build something like RASP or some of the traditional HPC codes, SPAC is fairly reliable to do that. There's this thing of people coming in expecting modules to be there. So they expect to go on a HPC system, module load, RASP, and someone's done that work for me, I don't need to worry about it. And then they might ask, well, can you upgrade the version? Can you add a patch to it? We didn't want to have to go down that route of having to sort of maintain modules on a global system for particular use cases for a project. We wanted to enable the projects to manage that for them. And then we've got the compiler flexibility. So C++ projects, Python, all require slightly different versions of GCC, or maybe if you're on NVIDIA GPU, you want to use NVIDIA compilers and all this kind of thing. So we didn't want to fix things to a particular compilers, so people could just use what they wanted. We also wanted to make sure the documentation had a consistent user experience. So one of the key things on that previous chart, that it was user services or user experience, where we wanted to make sure people had the knowledge and also a good experience of running software. And also, all of that has already been done out there by someone. If someone's already generated a package definition file to build a piece of software, SPAC makes it fairly easy to go to spac.packages.io, I think, and you can just type in your software package keyword or something like that, and it will look up and show you what someone's already done the work of building that software. So that's a bit of a selling point, sales pitch for why we chose SPAC. And so what we decided was, rather than trying to install a central version of SPAC and somehow make that work with each individual project and sort of try and maintain something centrally, we decided to go down of recommending an environment. So people are used to virtual environments in Python. People are used to isolating their environments. So SPAC can do that as well. You can have your own virtual environment. You can load it. You can then deactivate it, load up a whole new dependency chain. You can all do that there. You can also use standardized configuration. So we wrote the configuration for our systems. People download that, and then they can just build using that knowledge that it's been tested and been doing it. Okay, version control, that's a given. Simple activation, similar to Python virtual environments, and custom package repositories. So the containers, who uses containers here? I imagine most people do. Yes, we had to get that working. So we've got Podman, Aptainer. We've made sure the documentation is there. Difficulties around Slingshot and interconnect. Unfortunately, that's always going to be a problem where you get that integration with the host operating system and having to deal with that in containers. Storage, network file systems and containers don't seem to work very well. We need to have a solution for that, which we've got. And you can also build containers rootless mode on the thing. So you don't have that problem of trying to pretend to be root inside a container. It just works. So documentation underpins all of that. So we've made sure everything we do is documented. Any changes we do, any packages we make, we try and feed upstream into SPAC so other people take benefits of it. And the fact that we're using an ARM system makes sure that we are sort of leading the way in making sure ARM is a solution that can be used. So lessons learned, generally people are happy, people get on with things. We have started to deliver installing software tutorials and things like that on the documentation. Snagging point is the ARM architecture. It can be rather untested, especially with AI tools. AI tends to be containers built on x86 by NVIDIA. They pull them in, and they've got an ARM version of it, but the dependencies just don't seem to want to play ball if they try and install their own software. Steep learning curve with SPAC. SPAC is a bit complex to begin with, that concept of sort of isolating things. And the users just want things working. So look into the future. I think this is near the end now. The evolution of the RIC service, we've got the National AI Data Facility. AI is always evolving, always keeping pace, trying to keep pace to AI. AI is always wanting to be on the edge of the technologies that are available, so we have to try and do that. Evolution of the role of universities, so UKI funding, and we should expect the higher education landscape and the priorities that it's changing. So quick advert, open positions. I'm sure you can find it somewhere. Applications closed 1st of March. There we are. Hopefully I did that in a minute. So there we are. Quick credits to where credits due. Thanks to all our team members back in Bristol who supported on all this. And I think we're ready for questions. Is that on time?